You guys have a little more time. This is going to take you just a second to get this set up. I'm going to give myself lots of room just in case. Remember, you get a half a point just for keeping the right system. Did you at least get the first half point? Yeah. How many of you guys have reached the end? How many of you guys have tried? Look, 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 look. I want to see everyone's eyeballs. How many of you guys have tried something? Tried something? Okay, I'm not going to show anything until you try something. Every single hand has to go up and not just lying and cheating. If you need to try or have an idea to try something, let me give you a quick idea. You can either think of this cosine as cosine over 1 and get a common denominator by multiplying top and bottom by somebody. Or, you're going to have to do it eventually. Some people thought it'd be the best first step, or plug in for tangent the quotient property sine over cosine, and then try to simplify. I'm going to give you guys another 60 seconds. I can tell because of my recording timer. Go. Try something. Come on. You see it? Is it parentheses? Yeah. Yeah, because those are their parentheses around the one on this page. So the cosine has to come in. No, on top, you multiply across, and then you have cosine squared, cosine times cosine. And then the little cosine on the bottom. How many of you guys have tried something? Did Jason check it? David, did you try something? Okay, what do I mean by try something? Thank you, my other kiddos that raised their hands that did it the first time. If you just rewrite, you get a half point and then you get nothing else. For what could be like a 5-10 point problem. No, not saying it is a 5-10 point problem. Probably, probably 4 to 5. And this is probably a little bit more difficult than the ones you'll see on your quiz on Thursday. But listen, trying something. I can give you credit if you plug in something. If you do some legal math. I'm not saying every single one of you is going to see the exact path and go perfectly through without making any mistakes to the very end. That's unrealistic in life, right? Let alone Precalc, which is, well, its own little thing, right? Try something. If you get into a maze and you sit down, you're never going to get to the end. You've got to try something. Okay. I can get there eventually if you're sitting on the ground. Oh, you'll die eventually. Well, then you get to heaven, I guess.
Then you know what you're doing. He's got a
So he's basically saying if you don't like Precalc, you should sit down and then just wait until you die. Okay, let's not do that. Anyway, let's go ahead and zoom out on this so I can go ahead and see, and let's see how far we can get. Just because I heard some of you guys talking about it a second ago, let's go ahead and start by plugging in for tangent. So we have cosine of x, and the nice thing is for those of you guys that didn't get very far, you have plenty of time, as I am painstakingly working with my mouse that Mrs. Christensen is a a little busy, but she's going to help me with soon, or maybe Mr. Moffat today. Yeah, I need an admin passcode to be able to download any software. We have basically no power over our computer. If it was my laptop, we'd be good. Okay, I'm plugging in. Yeah, I know, it's dead. The problem is either Mac and Smart isn't like that. At least not with the license that we have. So all right, is that correct? Okay, I like it too. Now guys, can I give you points for this? Oh yeah, why? Because you legally used a property. I can give you points for that. You haven't gotten to the end. Some of you haven't even gotten close. Ayla, make sure you're paying attention to me, please. You haven't gotten to the end yet, but you do have something that you've taken a legal step in, okay? Try something. Now, most of you look at this and be like, ew, gross, there's a complex fraction. Perfect, so use that to keep going. My trick, you saw it yesterday with numbers and with trig. What am I doing and why am I writing a cosine x in the top right now? I'm finding, yeah, that yucky little stuck denominator that's giving me problems, and I'm multiplying careful, not both sides. I'm not doing the whole equation back forth, but top bottom. I'm multiplying top bottom of the piece with the yucky complex fraction by that nasty little baby denominator that's making problems. Now, hold on, help me out. You're gonna make mistakes if you don't remember the math. Not the trig, the math. When I'm multiplying fractions, I multiply across, right? So I'm gonna have, on top, cosine times cosine. Who is that? Cosine squared of x, yeah? All over. We'll get there in a second. Did I do anything to this first piece? No. Why not? Well, he didn't have a complex fraction, so I wasn't worried about him right now. I'll worry about him in a second with his common denominator or lack thereof, but we'll get there. Legally, what do I have to do when I multiply across the denominator? I heard someone say it louder. It starts with a D and ends with a ribute. Distribute. Because one denominator has two terms. I need to take this cosine and make sure he distributes to both pieces. Why am I saying that? Some of you would cross him out and say 1 minus sine, and you would be wrong. And you could try and try and try. Like the Japanese class that tried that impossible problem, and you're not going to get there because you just made it impossible with a mistake. Okay, so we can't make mistakes and make it easily to the end. Now, we can make mistakes, get stuck, and go back and say, uh-oh, this is harder than I think it's supposed to. Maybe I made a mistake. Let's learn from this, etc., etc. Not saying you can't make mistakes at all, but I'm saying in order to get to the end, we got to try to make it as legal as possible. What's cosine times 1? Cosine x. And what's going to happen to the cosine when I'm multiplying by sine over cosine? Good, the cosines are going to cancel. That was the whole point, to make everything a little bit prettier, and I have cosine minus sine. Now, we have a couple options. Some of you right now are like, this is hopeless. Stop. Look at the other side and say, oh, you know what? It's actually looking kind of closer. Look at that, right? But what's off? Do we want to change and make the signs better right now? What's off? Okay, how do we change, flip the signs? Yeah, if it helps, we can multiply top and bottom by a negative. This is one idea, one way of flipping the signs. If you don't like what they are, you can make them opposite, meaning you can flip the signs as long as there are two ways of thinking about it. Multiply top and bottom by a negative 1. Another way of thinking about it is factor out a negative 1. Both ways work. Both ways work. And either way you go about it, you end up with a negative times a negative. There's a positive up top with cosine squared of x. And on the bottom, what's going to happen to the signs? They're going to switch. Which means a negative cosine with a positive sign when we bring this negative 1 in, because this is multiplication. In case it looks funny, it looks like subtraction or multiplying. And isn't it going to look like this now? Okay, so let's go ahead and write it the proper way. So we have sine of x minus cosine of x. And what's going to happen to the signs? They're going to switch. Which means a negative cosine with a positive sign when we bring this negative 1 in, because this is multiplication. In case it looks funny, it looks like subtraction or multiplying. And isn't it going to look like this now? Okay, so let's go ahead and write it the proper way. So we have sine of x minus cosine of x. And as I'm finishing writing this, kiddos, look at the left. We still have that other cosine x over 1. What do we need to do with him in order to get closer to our final answer? Or to verify? We need to get a common denominator. So you need to take this side and multiply. Remember, common denominators multiply top and bottoms by the other denominator. You see him? Sine x minus cosine x, the whole shebang. Giving myself just a little bit more room. So I need that whole denominator. And remember, if we keep it legal, it's going to work out. Sometimes we might get a little lost in the process, but it's going to work out as long as we do things the right way. It's going to work out in the end, even if the in-between might be messy. Hey, life lesson kind of reminds us of chapel maybe from yesterday. But if we do a shortcut, and if it's illegal, just to make it easier in the step, guess what? You just ruined your whole problem, right? Keep it legal. You see I'm getting my common denominator? Multiplying top and bottom. Now what? Distribute. Now real quick, what if you had made a mistake up here? What if you had put 1 minus sine? You guys kept trying things. I can keep giving you points. You won't get all the points with the problem if you can't legally get to the end. But do the best you can. Do the best you can with the time given to you on Thursday. It's going to be a time quiz. You can't have a quiz on 2 sections, which is literally 1 piece of paper, like 5 problems taking the entire class period. But remember, with the extra time, you guys will start a new section. You'll keep working on it on Friday. We'll talk about that towards the end of class. But we distribute, and what do we get? Positive sine x cosine x. What happens when I do the second distribution? I already heard a negative or a subtraction. Good. Cosine times cosine is cosine squared. What can I do now that I have common denominators? Make it one full fraction, right? So good. I can also add the cosine squared now that I legally have denominators that match. My common denominator, remember, he stays the same. 1/3 plus 1/3 is 2/3. When you add 2 fractions, the denominator stays the same. He's just chilling. What do you see? What can I do? Ooh, yeah. We did everything legally. What we didn't want went away, and we end up with. Anybody have the original problem still written all nice and neat? How's it looking? The pronunciation is unique. Okay, sine x. And just for sake of time. Now guys, remember, if you're trying to get all the points, this isn't going to be multiple choice. It's going to be show me your work on Thursday. It's 5 questions, in-class quiz. Print it out for you. You want to make sure you're getting points for every step. As simple as, if you get all the way to the end, show it to me on the other side and somehow mark, haha, I'm done. You can put QED, you can put some sort of random. Someone was, I think in honors, was that the stick figure man? I don't know. Someone's doing a stick figure man. You do rubber ducky like George Corey. Maybe he was a T-Rex, I forget. Or just a simple check mark. I don't care. Now, technically, I'm going to tell you something just for sake of you getting all the points possible on Thursday, even if you get a little stuck on a problem. And it's actually, in some senses, really bad advice in real life, but it's good advice as far as me grading your quiz, okay? I want to see that you know how to properly show me everything for one of these T-proofs. So, that starts off with, you write, or you, I should say, you have the original problem. You're probably not going to have room to do all the work on the paper itself. There's going to be a backside that's blank that you can show work on. or you will have a cover sheet. You can also show it there, just staple it. You guys know what to do. If you write on a staple it, you need to read it. If you are doing a problem somewhere else, you rewrite just like you're supposed to. You make a T, you choose a side, that's a half point. Every legal step you make in the process, every legal jump you make, you'll get a point for, up to the maximum of however many steps it should have taken to solve. If you go a little bit wrong, you'll get some points deducted, as obviously I must do, because it's not going to be a legal proof. However, what if you got right about here, which wasn't very far, and you got stuck? Try things. But if you made a mistake, it's probably not going to work out. You can go back, try to find a mistake, and then fix it. However, if worse comes to worse, what you could do, just to show me, hey, I know what to do, I just can't get there. I know what to do, I just can't get there. If you get totally stuck, and because of time, because there are going to be a couple of these T-proofs, you need to move on. Could you do that? Yeah. No, you're going to get full points. No, you're not. But can I give you the final half point for knowing how to show the answer? Yes. Now hold on, why am I telling you this? Because so many kids go part way and they're having their integrity, they're like, I literally can't get to the end, and then I can't give them a half point for properly showing the final part of the proof. And then I have other kids who are totally trying to sneak around and be like, oh, I got there, and yeah, no, their work doesn't even closely show it. But they get the point for this half point. So I'm trying to make sure that all of you guys realize it is fine with me. I'd actually prefer it if you know your work doesn't match this, to give me a ... to say I don't know how to connect the dots. Does that make sense? So if time is running low, give me a ... show me the final. At least you get the half point for this, rewriting perfectly, exactly the side you choose. You get the half of the point for saying I know how to finish, or I know what the finished proof should look like, I just can't connect the dots. There's a joke about it, thus the miracle occurs. I think it might be on the website, but anyway, for right now, let's just leave it there. We'll look at it tomorrow. Alright, cool kids. Let's do one more example together, and then pretty much I'll let you guys do work. Sound good? Let's see which one I want to do though. This one we're not going to finish. We're not going to do, well, it's actually really easy. We'll do both examples with us. This one's really easy because it is a property. It's a property that we rarely ever use. Speaking of properties, I think someone asked me today and I just hadn't announced it yet. Remember I said whenever we're doing problems, you don't have to stress about having the formulas memorized? Which means on Thursday when I give you a quiz of problems, focus, Austin, you're going to want to hear this. Thursday, when I give you a quiz of problems, am I going to make you have all the formulas memorized?
No.
Nope, I'm going to have a reference formula sheet just for Section 5.1 formulas for you guys to be able to use along with the quiz. Sound good? I didn't want you guys to have to stress about that. So use your notes. Which side are you choosing? The right side? Yeah, no. I mean, you can. Some of you who really want to challenge. You could, but you'd have to think about what's on the left in order to help you out. Basically.
Oh, I see.
Okay, never mind. That's going to take too much time. Alright, so we rewrite. Make it a half point. Get that half point. Some of you guys are like, yep, I'm going for any point I can get. Do it. Don't lose silly points on silly things just because you're not following the process. I heard some people already say, oh yeah, that's a co-functioning thing. Sweet. What co-functioning thing is it? What's tangent of pi over 2 minus theta? Nope. Cotangent. It's his co-function. Go look at your table. You don't have to be guessing on this. As soon as you get here, hopefully some of you are like, what? Sweet, we have like one more step. Why? Yeah, we have two options. Do you want to use quotient properties or reciprocal properties? Alright, quotient properties tells us who is cotangent. Good. Cosine over who? Sine. He has a theta. We're going to write our arguments when we do our work, right? Quotient property. Who's tangent? What would you have to do?
Cotangent.
You have to multiply by tangent over tangent.
Yeah.
Then the 1 over tangent could be cotangent, and cotangent could be the cofunction. Easy, yeah? Guys, what happens if you have a sine over a sine and a cosine over a cosine? Everything reduces to b? Dun, 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 dun. Dun, dun. Have your properties close. You don't have to have them memorized yet. Ooh, but you should be memorizing them. Okay, I said we do both because that one was fast. What side do you think? Oh, yeah. Let's choose that one. This one, I wanted to make sure we got to. I did the last one because it was short. I wanted to make sure we got to this one because you have to be creative. Like how Ricky was like, hey, let's start with the 1 and we have to put stuff in ourselves, like tangent over tangent. This one, you've got to put something in ourselves, which makes it hard. Why am I choosing the left? Because he has a square root. Who likes that? But here's where you guys are like, can't you just square both sides? And I say no, and you should know why I say no. Why do I say no? No, you're normally with an equation you are allowed to square both sides. You can only work with one side. We're not allowed to work with both. It's not a proper verification of these. So we're going to have to figure out a way to get rid of this square root without multiplying on the other side. And yes, there's a very particular reason why I'm leaving lots of space. I rewrote it. It's there. You saw it, right? There's my half point. I don't want to rewrite it again. So, I left space. If we can't square both sides, the only way to go any further is to say, 1 plus sign, 1 minus sign sounds kind of like Pythagoreans if only they were squared. But we can't put a square on both sides. We can't put a square. But we can multiply by a conjugate, like we did with complex numbers, in order to try to transform stuff. Now there were only 2 options as to which conjugate to put. The struggle is we had the plus and the minus in the original. Can anybody figure out why I chose 1 plus sign instead of 1 minus?
Because it's 1 plus sign on the right.
Because you see 1 plus sign on the right, that might be one way, like we think he's pretty important. And maybe as we go on, it'll make more sense as well. But yeah, we can use that for right now. We see the 1 plus sign here, so we wanted him to stay. What happens when we multiply? Is the square root gone yet? Okay, good. The square root's not gone yet. Caleb is deciding to leave the top factored form. He's not distributing. He's not foiling. He's saying, okay, we have 1 plus sign times 1 plus sign, 1 plus sign squared. Can anybody see now why that's a really great idea? Square root squared, awesome. Oh, what? That's what I want at the end anyway. And some of you guys are wondering, why can't we just add or subtract or whatnot? We were multiplying. Keep your algebraic senses, wits about you. Bottom, are we going to keep it factored?
No.
What are we going to do? 1 plus sign, minus sign squared. The plus sign, minus sign cancels out because that's a difference of squares. I foiled it. I just canceled out the plus sign, minus sign in my head. 1 minus sine squared is a Pythagorean property, and a Pythagorean property that equals, I heard some of you say it, cosine squared. You guys like how much time you have to keep up with me now? But I'm slowed down. Hey, there are perks, right? Arthritis in my hand, and then you guys. Okay. You guys see that the squared and the square root are going to cancel on top and on bottom? Now you're lucky because you can see the other side, and maybe you can kind of cheat with this step and be like, oh yeah, I totally get why there's an absolute value on the bottom but not on the top. But they were both squared. Why isn't there an absolute value for both of them? Why? No, but good ideas. Not because it's the denominator.
Cosine.
What was the last one? I didn't hear what the last one was. What'd you say? Who was that? Jane? What'd you say? Kind of. I'm going to say kind of on that one. The top has more than just sine. What else does the top have besides sine? 1. The top had this whole quantity that was all squared. Now, cosine technically was squared too. It was just written in that nice notation. How it's in here instead of out here with parentheses. But sine did have this extra piece, hence why we had those big old nasty parentheses. Question. What sine values are legal or possible? -1 to 1. What's 1 plus -1? 0. What's 1 plus -1/2? +1/2. What's 1 plus 0? 1. What's 1 plus 1? 2. Wait, can this ever be negative if sine can't go below -1? Oh, well if it can't be negative, who needs absolute value? It's not possible anyway. But can cosine be negative? Ah. So I had to keep the absolute value for the only one that actually could be negative. The top can't be because of the range of sine. So that 1 did make all the difference. Dun 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 dun. Kiddos, grab out your spirals. If you haven't written down homework yet, I'm going to go ahead and show it to you. Please don't show me you're writing down homework because a broken foot is depressing enough. Alright, so. Just kidding, not depressing, guys, in control. I was just trying to make you feel guilty. Alright. While I'm getting your homework to show you, because you guys have the rest of class to work, and if some of you guys got stuck on ones last night, you can ask your group first and me second, because I'm just chilling over here. But let me first look at the calendar real fast as I get ready to show you your homework as well. Okay, real fast. Remember, today we were doing what? Finishing section 5.2 and having a partial work day on homework. Tomorrow, what are we doing? Oops, that was not the right thing. Where is that?
Where was that?
I have no idea. Homework is due tomorrow, fully attempted. We're going to do section 5.1 and 5.2 homework help and a review, probably with a few selected problems from the chapter review. Maybe getting people to the boards, maybe just my working through a few particular problems. So guys, today literally is a work day. Don't stress, do the best you can, attend everything, come in tomorrow with those you got stuck on, because who knows, maybe the one you got stuck on is similar to one on the quiz, right? Okay. And then, on Thursday, what are you guys doing for part of class? Probably for like half an hour of class, okay? It's going to be most of class. I'll give you guys time. Probably for half an hour. You have 5 questions. We'll say 2 to 3 from 5.1, 2 to 3 from 5.2, maybe even a bonus. We'll see. And you do get a formula page printed out. For the last 15 minutes of class, I will have an intro to section 5.3. Video, don't worry, Senior Brache will not teach pre-calc. If for some reason the video is too quiet or too loud, please feel free. He is a reasonable guy. Let him know. He will do what needs to be done. Don't just listen to a too quiet video the whole time. Yes, it's happened before and not know what's going on. Okay. On Friday, I'm going to have another video for section 5.3. Nice thing is, as you guys know, we have a 3-day weekend. If we come back, or as we come back on Tuesday with me, hopefully, Lord willing, I'll be here. We will finish section 5.3. The homework will be due on Wednesday. So, I need you guys to listen to those videos to get notes down on Thursday, a little bit Friday, the whole class period, but the nice thing is you have me on Tuesday before homework is due. Sound good? Okay, one quick note. I'm going to make it in the videos. For section 5.3, you have to remember your unit circle. You better be studying that thing over the 3-day weekend when you have extra time and no homework due on Tuesday. Get back to knowing your unit circle. Kiddos, homework, if you need to write it down, you guys can be working on it until the end of class, which is about 10, 12 more minutes. You can write down the cheater chart for the unit circle. You just have to have a way.
Will that help with the unit circle thing?
Yeah, probably. If you need to run and go get a book, I have a few right here. Like, alright, go get lost. Yes. Yes. Oh, and Blake, with everything I haven't emailed Senor, I think there's room on the DR.
Hi.
Hi! Oh, at least it wasn't in my face. If anybody got stuck, ask your group right away. Awesome for being productive, right?
Hey, how'd you get your locker so fast?
Oh, tail, look at this guy up here.
It broke. It's
Oh, it
not,
broke?
He didn't read it. It broke.
Is it not even close? Don't keep valuables in there.
Yeah. My life philosophy is not having anything valuable.
Be bold, be brave, ask questions if you're stuck. Now's the time. If you worked on it last night, you are
What's
amazing.
the answer to number one?
So ask the question.
Awesome.
Isn't it like a fill-in of a property?
Yeah, probably. And it's in the back of the book.
But guys, remember, don't necessarily use Snapchat on these because I think it might make it more confusing because they just kind of go and equals instead of a nice T. Make me T proofs. If I don't see T proofs, I think you're cheating. So I have to act on it. For your sake. Not mine. Makes more work for me. Alright, Dave, let's get some good work done. Awesome, let's get some good work done. If you don't have a book, borrow one. Share. Run to your locker. Take a picture with your phone of someone's page. I don't know. You guys knew we were working today. Ashley's coming. Take a picture of her page. There you go. Everyone around, not everyone. Maddie, thank you, Gavin. A lot of guys behind you need a picture of the page. I'm sorry. If no one in your group can help, guys, I'm chilling. I would love to help. Yes, I have basketball games after school, so I'm not going to be here.
Changing that and then putting it together. Is that the
This is illegal
what? Why?
because it has to be like terms.
Oh.
You were thinking like properties
Oh.
that. Now, what you can do, hold on. Can't you take a secant to the foot out?
Yeah.
Do that instead. Then there's a property. Yeah, then.
That's why I got like that.
I like that. One that is, you change too much. You don't have to change everything you can. Look at the answer. I like cosine squared.
Yeah.
Keep them the same. Just change the other.
Okay.
See?
Yeah.
Oh, yeah. I didn't do that either. Don't go change it yet. See the common factor of tangent squared. This is one. And pull him out. And what would you have left to the factor out of tangent squared? You can do that, right? Hold on, he's hiding. Okay, so you see how there's tangent there, and 4 tangents there, right? So if I take away tangent squared, big division. 1 plus, how many are left? So now you have secant squared tangent side, so I thought you were on that side. Leave that, because you want some tangents there. Split him up. The secant squared. Keep one of the secant squares. Convert the others using the back. So you're going to have a secant squared. A 1 plus tangent squared, and you convert in a tangent squared that you can distribute. Does that make sense?
Yeah, thank you.
More time. Anybody else wants to ask me a question? I don't bite. My scooter might, but I'll keep it still. That was a whole thing.
Yeah, it's this thing. I put it down there and then I equals it. But I was still working on this. I don't know.
Oh, okay. What you're doing is legal. You're changing tangent to sine over cosine. Totally legal. But I'm looking over here saying, oh, cosines and cosines. You want to keep this secant tangents. See what I mean? So I would stop.
Can you distribute this secant to the
You go to sine thing. You see what?
yeah.
I take away the fourth, I have 2, and I take away the fourth, I have a 1, so I divide.
Yeah.
Why is that good? Who is this?
It's a property of some sort.
Long story short, he's tangent squared. Wait, if that's tangent squared times tangent, it all works out. There you go. Nice. I don't even know. That's legal, right? It's totally legal. One, I call it a heart method. Because the other one had a denominator of tangent and a tangent squared had an unknown tangent. That's just remember how I was doing that one? And you can see what happens.
Negative 1 is what you want.
And I can look.
No, the negative 1 for 14. No, you want negative 1. Or what is cosine squared of beta minus 1? You want negative. Yeah.
That just fits, because you weren't using to doing that, right? That's
If you have, oh wait, oh. Yeah. No. Nathan. Nathan, the sine is equal to negative and then multiply that by 1. Ricky's right. Sine right. You have still you have the negative on the outside of the sine. So you switch the sign from negative cosine minus 1 and then
It's alright.
negative
Sometimes you just gotta hang in.
Oh, so you change sine squared to negative cosine. Oh, okay, so we change both. Okay. Awesome. Well, yeah, because it's but it'd be plus 8. Caleb, it'd be plus 1. And then you do that.
Blake, they're having like a powwow, 3 groups together or something like that. He was like, what's going on?
And Ricky, and Ricky. Nathan was saying
Probably don't need to be recording all